Today we are going to start on the other type of lane management, which is the HOV lane management, which is basically the high occupancy vehicle lane management. We're going to start straightforward with a case study to assess the feasibility for building or making an HOV lane. So here we have this case. Evaluate the addition of an HOV lane to a given freeway. The lane width, okay, 3.4 meters, number of lanes 6, 3 in each direction, peak hour factor 0.9, truck percentage 0 trucks are not allowed during peak hours. So that's the initial condition. The basic free flow speed is 100 kilometers per hour. Current volume is 4,860 vehicles per hour. Lateral clearance 1.2 meters right and 0.6 meter left. It's a freeway, remember, okay? Interchange density is 0.5 interchange per kilometer. Now, there is an occupancy rate survey study. And the occupancy rate survey study say that under the current condition, the percentage of one-person vehicle is 70%, two-person vehicle 18%, three or more persons vehicle 12%. The expected, if we implement an HOV lane, the number of people that are going to be, carpooling together is expected to increase. So the number of one-person cars is expected to drop to be 85%, as you can see here. So there's a drop from 70 to 85%, and there's an increase in the two-person vehicle to be 20%, and in the three-person vehicle to be 22%. Now, the question is, estimate the new level of service for the HOV traffic and the average level of service, okay, for the freeway. Clear? So let's work on this case, and let's see how we can, first of all, we are going to start with the initial case, which is basically is what we have here. So here we want to start. First, we need to convert the trips into person trips. So we have 4,860 vehicle per hour. Okay, so we want to convert this into person trips. So we have out of this, we have 70%, 0.7 multiply 4,860 multiply 1 plus 0.18 multiply 4,860 multiply 2 plus 0.12 multiply 4,860 multiply 3. This will be the number of person trips we have. So basically, we will end up with 0.7 multiply 1 plus 0.18 multiply 2 plus 0.12 multiply 3 multiply 4,860. So if we take the 4,860 as a common factor, we will end up with 1.42 multiply 4,860. So we will have here, we have 6,901 person trips per hour. Let the new volume equal V. Traffic volume. Okay, and let's see الترافيك فوليوم ده هيبقى عندنا فيه V 0.58 multiply V plus 0.2 multiply V multiply 2 plus 0.22 multiply V multiply 3 equal 6901. بمعنى احنا what we are doing now, we are saying that the new volume will be V, that's the number of vehicles, and we are going to convert this volume into the same person trips. So we're going to multiply V by 0.58 multiply 1 plus 0.2 multiply and so on. So we will get that we have the new traffic volume will be 0.58 plus 0.2 multiply 2 plus 0.22 multiply 3. So we have 1.56 V equal 6,901 person per hour. Okay, so the volume here will be 6,901 divided by 1.56, and this will be vehicles per hour. This is going to be 4,423 vehicles per hour. See, there is a reduction in the total traffic volume. So now we want to assess the level of service in the weaving in the HOV lane and in the non-HOV lane. So here we have the volume or the traffic volume in non HOV equal 0.58 multiply 4,423 equals, so this multiply 0.58, it equals 2,569 vehicles per hour. Traffic volume in HOV lane equal basically 4,423 minus 2,569 equals, so this minus 4,423. This is assuming that we have case 1, which is basically this is 2 plus HOV lane. So this will be 1,857 vehicles per hour. So that's case 1. 2 plus HOV lane. Case 2, where we will allow only the 3 plus HOV. So in this case we will have the traffic volume يبقى هنا traffic volume in non HOV equal 0.78 multiply 4,423. So this will be 4,423 multiply 0.78. So we have here 3,449 vehicle per hour, and traffic volume in the HOV lane equal 0.22 multiply 4,423 equals. So it's 973 vehicles per hour. Okay, so now let's start and see how we are going to evaluate level of service. So we're going to do the LOS analysis here. So let's see the level of service. So for the current case, what do we have? We have 3 lanes, so we need to adjust the free flow speed equal. We have the free flow speed, it was here, I think, 100 kilometers per hour. So we have 100 kilometers per hour minus, we need to have an adjustment factor for the lane width. Okay, so now we need to adjust the free flow speed. So we have the lane width, it was 3.4, so the adjustment is minus 2.1. So we have here, that was 100 minus 2.1, that's the factor for lane width. Then we have another factor for the right hand lateral clearance. So the lateral clearance we had here, it was 1.2 meters. Let's look at the schedule at the table here. For the factor for the lateral clearance, we have right hand shoulder, it was 1.2, I think it was 1.2, right? Yes, 1.2. So we go here, number of lanes in one direction 3, and we have 1.2, so the reduction factor is 1.3. So here minus 1.3 minus the other factor will be the density of the interchange factor for interchange density. We have 0.5 interchange per and there's another factor for number of lanes. So the interchange density we have 0.5. We go here and number, okay, no, that's the adjustment factor for number of lanes. It's 3, so we have 4.8. So this is minus 4.8. And for the interchange density, we have 0.5, so it corresponds to 2.1. So here's 2.1. So the free flow speed will be 100 minus 2.1 minus 1.3 minus 2.1 minus 4.8. That will be equal to 89.7 kilometers per hour. So that's the free flow speed. Let's check on the volume per lane, VP, equal basically volume divided by peak hour factor, number of lanes in one direction, HOV, and the population density, population factor. So we have the volume here is 4,000. Let me just 4,860 divided by peak hour factor. How much was the peak hour factor? The peak hour factor, it was 0.9 over here. So we have here 0.9 multiply number of lanes in one direction is going to be 3, and for the heavy vehicle factor, trucks are not allowed, so this is going to be 1, and the population factor, it's 1. So the volume, the adjusted volume per lane will be 4860 divided by 3 divided by 0.9. It's going to be 1800 passenger car per lane per hour. So now we want to calculate the density. In order to calculate the density, we have to do this. Calculate VB divided by S, which is basically the speed. And the speed in this case is going to be varying because the volume is 1800, so that's beyond the limit. Let's go and check on the charts here to see how we're going to do that. So that's basically what we did for the adjustment, volume adjustment. That's the heavy vehicle factor. Okay, so here we need to check on the volume. Basically, our volume is great, it's greater than 1800. So we need to adjust. Let's look at the chart. Yes, our volume is somewhere here. It's right in the middle. And we have our speed is almost 90. We can get it from the graph. Okay, so we almost here. We can assume that, that's the threshold for the linear function. Okay, so we can assume that it's going to be more or less the same. The speed almost equals to the free flow speed, so we can use it here. So here is going to have 1800 divided by 89.7, so the density will be 89.7. So we are going to have a 20 passenger car per hour per kilometer per lane. So that's the density. That's a level of service equal D. That's the current case. Let's check level of service in case when we have an HOV lane. So here LOS with HOV lane in place. So we have option 1, case 1, which is 2 plus HOV lane. So let's check on the HOV lane level of service. HOV LOS. We need to adjust the volume to be a passenger. The free flow speed is, we're gonna assume, is gonna be the same, like in the base case. So the level of service, the VB in this case, VB for the HOV equals, we have 1857 divided by 0.9, 1 multiply 1 multiply 1. So basically we will have here 1857 divided by 0.9. Okay, so it's going to be 2630 passenger car per hour per lane, and that's the volume if we apply the 2 plus HOV lane. Okay, so in this case, basically the level of service will be, let's check the density. The density will be 2063, and here let's go to the chart. We have the speed, it's almost 90, so we have 2000 is here, so we're gonna be E. So let's assume it's going to be somewhere the free flow speed. The speed will be reduced almost to this value. $88. So the density will be 23.44 passenger car per kilometer per lane. Level of service equal E. What does this mean? This means that those that are expecting to use the HOV, they are going to be suffering more. That means they are better off not to drive through that lane. The main idea of having this HOV lane is to have a less density in that lane. The density will be less than the other lanes, and people will be attracted to it, so they can drive faster and have a better mobility. But in this case, so to start with, this case is rejected. Because basically, nobody's going to get advantage of driving through that lane. So let's go to the case 2. Case 2, which we are limiting only the HOV lane to only vehicles with 3 or more passengers. So let's check on the volume VB that's in the HOV equal, let's get the volume from here. It's going to be 973. 973 divided by 0.9 multiply 1 multiply 1. So that will multiply 1. That will be 973 divided by 0.9 is going to be 1081 passenger car per hour per lane. And of course, this were in the linear part, so the density equal divided by 89.7. So here we have 89.7. We have 12. That's wonderful. Passenger car per kilometer per lane. That's the density. The level of service in the HOV lane will be, I think this is C or B. It's going to C, upper C. So basically, people will tend or try to use it. Let's check how is the situation in the for the non-HOV lane traffic. So here VB non-HOV equals 3,449 divided by 0.9 multiply 2 lanes, because the remaining are going to be 2 lanes that for the non-HOV traffic. So 3,449 divided by 0.9 divided by 2. So here's going to be 1916 passenger car per hour per lane. Let's check from the chart and try to get the new. So here that's the 18. Okay, that's the speed. So it's going to be moving somewhere here. And we are still near the linear part of the So here we can say that S equals almost 89, not, we're going to remove the 0.7 kilometers per hour. You can substitute in the equation and, get the actual value, but it's going to be in that range. So the new density for non-HOV equals the new volume, 1916 divided by 89. So it's 21.5 passenger car per kilometer per lane, which is level of service equal D. That means we didn't, things are still acceptable, because in the original case, the density for the entire road was 20. But now we have part of the traffic is driving at level of service C, and those that are not, moving to be, to carpooling together, they are still almost unacceptable, because here it's 21.5. The increase, the delta is only 1.5 passenger car per kilometer per hour in the density, and still the level of service almost the same. So in this case, this one is accepted. Okay, and we are gonna go with this one, and it's feasible to apply this situation. Any questions so far? Okay, thank you.